Good morning to all of you. Last class we have seen NCERT numericals from exercise for concave and convex mirror. So today we are going to explain refraction of light. When light travels from one transparent medium to the other transparent medium, for example, air to water, air to glass, water to glass, etc. So when light travels from one transparent medium to the other, a part of light is reflected back into the same medium, obeying the laws of reflection, and the remaining part is refracted, mean passes through the second medium. So when a light travels from one medium and reaches the interface between the first and second medium, and if the light comes obliquely, that means makes an angle with a normal oblique incidence, then it changes its path when it is going to the second medium. So this phenomena we call it as refraction. The change in the path of light, especially we say obliquely incident light, when it goes from one medium to the other transparent medium. So this phenomena we call it as refraction of light. During refraction of light, there will be change in the velocity of light, there will be change in the wavelength, but there will be no change in the frequency. So this is a very important point. So during refraction, frequency remains constant. Velocity will change because it is going to the next second medium, and wavelength also will change. Whereas the frequency remain constant. Why frequency remain constant? You will see in higher classes. So different types of mediums are there. Light can travel from water to air. Light can travel from air to glass, air to water. Different of mediums are there. So we'll go for the diagrams for that. When light travels from air to water, air medium we call it as a rarer medium, and water we call it as a denser medium. When light travels from air to glass, then air is a rarer medium, glass is a denser medium. How we recognize which medium is rarer and denser, etc., we'll see along with the diagrams. Okay? Yes, we'll see the screen. So refraction of light means it is the phenomenon of change in the path of light. That you have to remember, it's a change in the path of light. When light enters obliquely means making an angle from one medium to the other. So when a beam of light reaches another transparent medium, a part of light gets reflected back into the first medium while the rest enters the other. So the direction of propagation of an obliquely incident light, that enters the other medium, changes at the interface. So this phenomenon is called as refraction of light. So during refraction, velocity changes, wavelength changes, but frequency remains constant. Frequency remains constant. So take care of this definition. So the direction of propagation of an obliquely incident ray of light that enters the other medium changes. Change in the path of light when it goes from one medium to the other medium at the interface. That is known as refraction. So generally when we see a medium here, so during refraction of light, it is change in the path of light when it goes from one medium to the other medium. Okay? And velocity will change. There will be change in velocity. There will be change in wavelength. But frequency remains constant. Frequency remains constant. We know the relation involving them, C equal to nu lambda. velocity is given by c equal to nu lambda. So change in the path of light when it enters obliquely, oblique incidence. The word you can write obliquely. We'll see that what is oblique incidence. Suppose we are taking two medium here. This is air medium and this is water. So you take a point here. You can make a normal perpendicular is drawn. This is normal. Light travels here in this way. This is called oblique incidence. This is incident ray, and the angle between incident ray and normal we call it as angle of incidence. So angle of incidence is angle between incident ray and the normal. This is the point. So this red line stands for the separating surface between air and water. Now what will happen to this ray? So it is going from air to water, changes its path. How it changes? So it is water is a denser medium, air is a rarer medium. Why? Because light travel faster in air and velocity of water will be less. So in that way we recognize which is denser and which is rarer. So that is the easiest way. So which if light finds difficulty to move or if its velocity is less in a medium, we say that that medium is denser compared to the other medium. So this light ray bends toward the normal here. This is the bends toward the normal. So this ray we call it a refracted ray. And this angle is known as angle between the normal and refracted ray. We call it as angle of refraction. So what is the initial direction of light? Initial direction of light is this. This is the initial direction of light. So this is an oblique incident ray, and this if you continue this, it goes like this. But when it reaches here, bends toward the normal, change its path. So it is changing its path in this way, changes its path. At the same time, there will be some part of the light will be reflected back by obeying the reflections. So this is some part of the light will be reflected also, and the remaining is passing through the next medium. So there will be change in the path. This phenomenon we call it as refraction of light. So I repeat, what is the meaning of refraction of light? It is the phenomenon of change in the path of light. So all should learn this. Change. Okay? Change in the path of light. Change in the path of light. When it enters obliquely, you can see that from one medium to the other medium. You can see that the interface here. This is an obliquely incident ray. Reaches the interface between air and water. Air we recognize as a rare medium because velocity is faster. Water velocity of light is less there, so it is recognized denser medium. So when it goes, velocity decreases. So the refracted ray bends toward the normal. So this is the initial direction of incident ray. It cannot go in this way, changes its path in this way. So in this case, you can see refracted angle of refraction is less than angle of incidence. It is a rarer to denser refraction. Rarer to denser refraction. So some part of light is reflected. We are not interested in the reflected light. That part is already over. So we discuss mainly refracted light. Suppose light travels from water to air. Water velocity finds difficulty, restricted, velocity is less. But when it goes to air, it's free to move. Okay, so its velocity is faster. So it will be denser to rarer. That also I am going to mark. Next one. Suppose if it is moving from light is traveling from water and water to air. So water will recognize as a denser medium and air we recognize as a rare medium. Okay, you can make the normal at any point. This normal is made. And this is your incident ray. This is incident ray, IR. It makes angle I with the normal. Incident ray, angle between incident ray and the normal is known as angle of incidence. Okay, so it's a denser medium. The velocity of light is less. There are restrictions. But when it is coming to air, it is very free. So it goes away from the normal, very free. If it is very free, goes away, far away from the normal. So it goes in this way, going away from the normal, going away from the normal. And this is a refracted ray. And the angle between refracted ray and the normal, R. And what is the initial direction? Initial direction of incident ray is this. This is the initial direction. So from incident ray direction, it deviates, it changes its path. So in this case, angle of refraction is greater than angle of incidence. So you have to recognize these points. So two refractions diagrams are there. In figure 1, first diagram, this is a figure 1 and this is figure 2. In figure 1, what you see is a refraction from air to water. Air is a rarer medium and water is a denser medium. How you recognize which is denser and rarer? That we recognize by recognizing the speed of light. The speed of light in a medium is less, that medium is considered as denser because it gives more opposition to the light. Oblique incident ray, this is the initial direction, bends toward the normal because velocity decreases. Here it is, water to air. When it comes here, velocity increases, going away. So when velocity increases, goes away from the normal. When velocity decreases, comes toward the normal. So two refractions we mark there. One is from rarer to denser in figure 1 and denser to rarer in figure 2. So change in the path of light when it enters obliquely. Why we use the term obliquely? Otherwise, what will happen? If a light is traveling straight, just see here. If a light is here, this is the air medium, this is a water medium. So this is the normal instead. If light is coming along the normal, it will not bend anyway, it will not change its path. It straight away goes. Yes, it's a normal. If the light ray goes along the normal, air to water, it goes straight itself. There will be no change. That is the difference we say oblique incident. It should make some angle with normal. And what are the factors that remains constant during refraction? Very important point. Only one parameter remains constant, that is the frequency. Why it remains constant, you will learn in higher classes. Other two things changes. Velocity will change and wavelength will change. Okay, so you have to remember the point this. Now we go for laws of refraction of light. Next point, laws of refraction. Laws of refraction. First one is, you can see a diagram again here. So I am drawing from air to water. Air is rarer medium, water is a denser medium. Oblique ray, this is oblique incidence to the point normal is this. Angle of incidence, this is incident ray, bends toward the normal. Coming to the normal, pass me. So this angle is known as angle of refraction, R is less than I, and this is the initial direction. Yeah, bends toward the normal. So there are two laws. First one, we say that you can see incident ray. Incident ray, normal, refracted ray, all lie in the same plane, plane of the paper or plane of the board, plane of the screen. Exactly similar to that of reflection. There is no change. So first one is your incident ray, we write IR, normal and refracted ray all lie in the same plane. All lie in the same plane. Plane of the paper, plane of the board. Incident ray, normal and refracted ray all lie in the same plane. Same plane. Second one, we call it as Snell's law of refraction. It is very important. What is Snell's law of refraction? Very important. Snell's law of refraction means you measure this angle sine I, this is R, the ratio of these two things. The ratio of sine of angle of incidence. Okay, sine theta, cos theta. You are all familiar with sine theta, how you know how to find out sine theta, tan theta from a triangle, you know, properties of sine theta, cos theta, how to calculate. Instead of theta, we'll write it here I, sine I. That is sine of angle of incidence upon sine of angle of refraction. I can be 30 degree, R can be some other value. When you take the ratio, sine I by sine R, you know the different values of sine 30. What is sine 30? You know the value. What is sine 60? So, similarly, here any angle can be the sine I upon sine I. The ratio of the sine of angle of incidence to 2 mean divided by sine of angle of refraction is a constant for a given pair of media and which is called refractive index. Okay, this is called refractive index and I write this as of second medium with first one. This is called refractive index. It's a term we are introducing, refractive index of second medium with respect to first medium. This is called Snell's law refraction. So, what is Snell's law refraction? It's defined as sine of angle of incidence, sine of angle of incidence upon sine of angle of refraction is a constant for a given pair of media, and that constant is represented by n to 1. First medium is here, this is the medium number 1 and this is medium number 2, and we write it as n to 1, and this is known as refractive index of second medium with respect to first. It's a constant for a given pair of media, and this is known as Snell's law of refraction. Snell's law of refraction. So it's a very important one. State lens Snell's law of refraction. I write the equation correspondingly. And so, what is the meaning of actually when you introduce a term here? What is the meaning of refractive index? What is this meaning? Refractive index. It's a term you can use for optical density of the medium, or you can see that the extent of the change in the direction of light that takes place in a given pair of media that can be expressed in terms of refractive index. Up to what extent it changes its path, bends toward the normal or away from the normal, that can be expressed in terms of the refractive index. Or that also represents how fast or how slow the light can travel in a particular medium. So, it's a term refractive index that gives you different parameters. When light travels from one medium, transparent medium, to the other transparent medium, of course, there will be change in the path of light. It can come toward the normal, we say that bends toward the normal. It can go away from the normal, we say that bends away from the normal. So, the extent of the change in direction that takes place in a given pair of media that may be expressed in terms of refractive index, that is a constant, and we call this as n to 1 refractive index of second medium with respect to first medium. And we can represent this refractive index in terms of velocity of light too. Okay, suppose light is traveling here with the velocity v1. First medium velocity of light is v1, and in the second medium velocity of light is v2. First medium velocity of light is given as v1, second medium velocity of light is given as v2. So, refractive index of second medium n to 1, this can also be written as the speed of or velocity of light in the first medium. Velocity of light in first medium divided by velocity of light in the second medium. This is also a very important one. So, refractive index is a constant for a pair of media. This can also be related to the velocity. Velocity of light in the first medium upon velocity of light in the second medium. So, we write this as n to 1 is equal to v1 divided by v2. Another very important relation. So, it represents some light travels from rarer to denser. Air medium is a rarer medium. Water is a denser medium. When light travels from air to water, what will happen? The velocity increase or decreases? Velocity decreases. So when light travels from rare to denser, the velocity of light decreases. When light travels from denser to rarer, velocity increases. So how this is related? N to 1 equal to V1 by V2. So very important term. So two equations are in front of you. One is here, that is by Snell's law. It relates angle, angle of incidence and angle of refraction, I and R. I think you remember when light travels from rarer to denser, angle of refraction is less than angle of incidence. In the previous diagram we have seen. And when light travels from denser to rarer, then angle of refraction is greater than angle of incidence. So sin I by sin R equal to n to 1, which is known as Snell's law. So it's a refractive index. It's a term used to represent up to what extent the light ray changes path. It represents how fast or how slow light can travel in a particular medium, or you can also say that optical density of the medium. Which one will oppose the light more effectively? If the opposition is more, velocity will be less. So that medium will be more denser. So this is the way how will you compare. So n to 1 equal to v1 by v2, velocity of light in the first medium upon velocity of light in the second medium. Next, very important point I want to just give. What is the unit of refractive index? Unit. Refractive index is a ratio of sin I upon sin r. So there will be no unit. It's a number. Its ratio velocity is v1 by v2. So refractive index n to 1. Okay, and it has no unit. No unit. It's a ratio of the same two quantities. Velocity upon velocity. Unit cancel. So it has no unit. Very important. It is represented by the letter n to 1 or simply nb. You can use it. Okay, but no unit. Next, one more point I am adding. What is the absolute refractive index? Absolute refractive index. Absolute refractive index means if the first medium is air medium or vacuum. Okay, first medium is air or vacuum. What is the speciality of air or vacuum? Because air or vacuum, the velocity of light is 3 × 10⁸ meters per second. That is the maximum value. So we take it as air or vacuum. Air or vacuum, velocity of light c is equal to 3 × 10⁸ meters per second. The velocity nearly equal, so we take it as, for practical purpose, equal value. VACUUM, vacuum. Vacuum spelling is VACUUM. Okay, this is the vacuum spelling. VA, only one C, double U are there, UUM. So the medium air or vacuum, velocity of light is, we take it as same value, it is 3 × 10⁸ meters per second. This is the maximum velocity of light pulse. This is the maximum velocity. So if the first medium we are recognizing it as air medium or vacuum, air or vacuum. The first medium is air or vacuum. And second medium can be anything. Then the refractive index, what we calculate, it is known as absolute refractive index. Absolute refractive index. Absolute refractive index. So n to 1 is equal to velocity of light. In the first medium, it is air. Velocity of light in air or vacuum, which is of same value 3 × 10⁸. All should remember, divided by velocity of light in the second medium. Okay, in the second medium. So this equation will write it as n to 1. Velocity of light in air or vacuum usually we represent by letter C. Velocity of light in the second medium we write it as V. This is the common equation. N to 1 is equal to C by V, or simply we write as N equal to C upon V. And whenever you write n, it is a refractive index of denser medium with respect to rarer medium. It is c upon v. Very important relation. So this equation you can calculate what will be the velocity of light in a particular medium. So velocity of light in a particular medium can be calculated in this. N equal to c upon v. Okay, so particular case, so light travels from air to water. What will be the velocity of light in water? We can calculate by using this equation, providing you know the refractive index of water with respect to air. Some examples I am going to give here. So next point. So this is called absolute refractive index. N is equal to C upon V. First medium is air or vacuum. Our second medium is any medium, denser medium. Any medium you can take. N equal to C upon V. Where the value of C, all should remember, it is 3 into 10 to the power 8 meter per second. That you have to remember. Okay. What are the refractive index of water with respect to air, common, and glass with respect to air? Suppose light travels from air to water. Refractive index is 4 by 3. This is 1.33. You have to learn this. Suppose light travels from air to glass. Refractive index is 3 by 2, that is 1.5. So at least you have to remember these two values. Refractive index of water with respect to air is 1.33 or 4 by 3. Refractive index of glass with respect to air is 3 by 2, 1.5. So I am writing three medias here. One is air is given there, then water, then glass. Out of these three, in which medium the velocity of light will be minimum? So greater the refractive index, greater the opposition. Greater the refractive index, greater the opposition. For water it is 1.33. Glass it is 1.5. So when light travels from air to glass, the velocity will be minimum. So glass, the velocity will be minimum. V is minimum in the glass because greater the refractive index, then velocity will be minimum. So when refractive increases, velocity of light in that medium decreases. Remember this point. N equal to C upon V. So if as a numerical from NCERT here, I am discussing numerical from NCERT. Suppose light travels from air to water. What is the velocity of light in water? What is the velocity of light in water? Light in water. Equation is N equal to C upon V and V is equal to C by N. Value of C is known to you as 3 in 10 to the power of 8 and N, refractive index, it is 4 by 3. Okay, it is 4 by 3. Refractive index of water with respect to air, we write like this, is equal to 4 by 3, that is equal to 1.33. So this is equal to 9 upon 4 into 10 to the power of 8 meter per second. So what will be this value? So this is the way how to calculate. So refractive index of water with respect to air is 4 by 3, that value you have to remember. 1.33, that is equal to 4 by 3 value you have to remember. And the value will be equal to, you can calculate the value, 9 by 4 equal to 2.25. It's equal to 2.25 into 10 to the power of 8 meter per second. Value is very less, 2.25. In air, the value is 3 into the power of 8. Now in water, the velocity will be less, 2.2. Velocity of light decreases. Similarly, you can also calculate what will be the velocity of light in glass in the same way. Okay, that also you do this. You can complete yourself. Numerical number 2, air to glass. Air to glass. Suppose air to glass. What is the velocity of light in glass? You can calculate the value as a numerical number 2. All of you can calculate. Again, same equation. N equal to C upon V. V equal to C by N. 3 into 10 to the power 8. Now, what are the things you have to change here? Instead of 4 by 3. So, here you have to write what will be the changes are here. So, N equal to 3 by 2, that is equal to 1.5. This is the refractive index of glass with respect to air. So, just N to 1 we write. So, here N we write it as 3 by 2. So, you are getting it as value will be equal to 6 by 3 into 10 to the power of 8 meter per second. That is equal to 2 into 10 to the power of 8 meter per second. So, you can see in glass again the velocity is less than that in water. In water it is 2.25. Now in glass it is 2. Again decreases. So, as refractive index increases, the velocity of light decreases. So, these are the different points in this section. So, refraction means change in the path of light when it goes from one transparent medium to the other. Rarer to denser, you can recognize different medium: air, water, glass. In the glass, velocity will be very, very less in comparison with air. Also, in water, if you compare with water, also we say that it is less. Velocity of light is minimum in glass. So, when you take air and water is denser medium. When you consider air and glass is denser. When you consider water and glass, can you tell me which is denser? If light travels from water to glass, of course, light can travel from water to glass. Then we say that glass is denser than water. Glass will be a denser medium. It's a very important point. Okay, so as you can mark as a note, water to glass. When light travels from water to glass, will the velocity increase or decrease? Again decreases, because water will be acting as a rarer medium, glass will be acting as a denser medium. Some other points will explain the next class. So this is about the refractive index. You have to define refractive index by Snell's law and in terms of velocity, and see the numerical also. So this is recognized as an optical density or the extent. Refractive index means the extent of the change, okay, that actually takes place in a given pair of media. That can be expressed in terms of refractive index. The extent of the change in the direction, the change in the path. So that can be expressed by this. Velocity can be recognized by this term, refractive index. And remember, it has no unit, it's number, just like a 4 by 3, 3 by 2, etc. Other points will continue in the next class. So necessary diagrams, all of you should make in the copy. Thank you.